Thermodynamics is a science that deals with heat and work. It's a science that deals with heat and work and those properties of matter that relate to heat and work. Let's start with the terms, definitions of terms. You need to acquaint yourself with what a system is, right? So when we talk about system in a thermodynamics, it's basically a region that is set aside for investigation. Now, class, we have different types of system. We have the open system, we have the closed system, and we have isolated system. So from system, please put down, we have open system, we have closed system, and we have isolated system. Please, you need to know the difference between three of them, because if you go to your past questions, most of the times they'll make the statement and they put that. Please put down. An open system is a type of a thermodynamic system that allows the exchange of both energy and mass across the boundary between a system and its surrounding. Full stop. Now, I want to define three of them, then I'll start explaining one after the other to save time. Now, let's write down closed system. Closed system is a type of a thermodynamic system that allows only the exchange of energy across the boundary between a system and its surrounding. Note, in closed system, mass is not exchanged. Note, in closed system, mass is not exchanged. Now let's look at the last guy before we dive into explanation. Isolated system is a type of thermodynamic system that doesn't allow the exchange of both energy and mass across the boundary. The type of a system that doesn't allow the exchange of both energy and mass across the boundary between the system and its surrounding. All right. So I want to explain this guy so that we'll look at number 2. Let me just write it down so I won't forget it. We have surrounding. Number 3, we have boundary. Number 4, we have universe. Now, under the terms, the first one was a system, which I further stated that we have 3 types of system: the open, the closed, and the isolated. So in case of exam, they could say a type of system that allows the exchange of only energy across its boundary is dash. What is the answer? Closed system. It's very simple. Please, this guy allows exchange of both energy and what? Another word for energy is what? Heat. This guy allows exchange of both energy and mass. This guy allows only the exchange of energy, right? And this guy does not permit or allow exchange at all. Do you understand? Now let's look at surrounding very fast. Surrounding is a space outside the system. Surrounding is a space or region outside the system. Full stop. It is usually restricted to the region very close to the system. It is usually restricted to the region very close to the system. It is usually restricted to the region very close to the system. So when I say surrounding, I give you an example. If you're boiling water inside your kettle, your entire kitchen does not make up the surrounding. What makes up the surrounding is just a small space around the kettle, which is the stove itself or the gas. You cannot say your entire kitchen is a surrounding. Nope. right? Now, it is usually restricted to a region outside the what? So if this is your system, surroundings should be somewhere here, not your entire system. Do you understand? So let's look at boundary. Please put down. A boundary is a separation between the system and its surrounding. All right, so now let's look at universe. A universe constitutes the system and its surrounding. And its surrounding. Now let's look at calculation and first law of thermodynamics. First law of thermodynamics. Class, thermodynamics has 4 laws. We have the first, the second, the third, and the fourth. But for Chem 130, or for the purpose of this course, we're just going to stick to the first law. Second semester, we'll look at the second law. Please put down. First law of thermodynamics states that the total energy in the universe is constant because energy can neither be created nor destroyed in any physical or chemical process, but can be converted from one form to another. First law of thermodynamics is about energy and its conservation. First law of thermodynamics is about energy and its conservation. Take note of that. First law is about energy and its conservation. The second law is about entropy and spontaneity. Now, Claire, listen up. Let me just explain this now, just in case. Second law of thermodynamics is about entropy and spontaneity. What did I say? Entropy and what? Spontaneity. Now, let me just explain this briefly, just in case. Now, when they talk about spontaneity, spontaneous process are those processes that occurs on its own without the aid of an external force. For example, water will always fall down a hill. Like you never see water going from down to up without the use of a pump, right? But you can see water moving from up to what? Down without a pump, is it not so? So those are spontaneous processes. Just in case of exams, you're being asked, what is a spontaneous process? Or what is a spontaneous reaction? When they say something is spontaneous, it means it can occur on its own without the aid of what? External force, right? So second law of thermodynamics is about entropy and spontaneity. Okay, so that is that. Let's come back to first law. Now, mathematical statement of first law of thermodynamics. Every law, most of the laws in chemistry always have their statement. Boyle's law has mathematical expression. Charles' law, all of them have their expression. So what is the expression of first law of thermodynamics? Now, delta E is equals to Q. Now, class, stick to it. Your textbook has minus. Both of them will give us the correct answer. It's not just about this. I'll use a plus, and I'm going to use a minus. But the plus is the most generally accepted. Delta E is change in internal energy. Change in internal energy. Q is heat. Class, if heat is absorbed, there should be a positive sign. That means it is endothermic. If heat is absorbed or gained, there should be a positive sign because heat has a sign. A system gains 50 joules of heat. Gains means it's absorbing. Plus, a system loses 10 joules of heat. You must add the minus. If you don't add the minus, you fail the question. So heat and work, they have conventions. So heat is same thing as enthalpy. Enthalpy plus enthalpy is endothermic, minus enthalpy is exothermic. So if heat is lost, is what? Negative. Okay, class, this part, I'll ask us to pay close attention to this part. Please pay close attention to this part, because whether here is plus or here is minus, the only difference is going to be this statement. If I change, please listen up. If here is plus, please listen up and hear what I'm about to say now. Q is constant. We already know that we have exothermic and we have endothermic, right? If heat is lost or heat is evolved, that's exothermic. If heat is gained or absorbed, that's endo, is it not so? So this one is constant. So, but you see this work, this is where we're going to be having some issues. Most students will have issues. Class, most times you hear, calculate the change in internal energy when so and so does work. Class, the system is the opposite of the surrounding. If the system should do work, the surrounding is the one to feel the impact, because both of them are opposites. If system is pushing, right, who is feeling the pushing? The surrounding. If surrounding is pushing, who is feeling it? So if I say work done by the system is same thing as what? Because if the system is doing the work, it's doing it on the surrounding. So most students always cram this by the system, forgetting that there's what? On. So look at this. If work is done by the system, work will be what? Negative. So you come here, whatever the value of work was, you're going to add minus in front of it. That is just the concept. That is why we say this is sign convention. Now, if work is done on the system, class, when the system was the one doing the work, it was done on who? If the surrounding is now doing the work, it's being done on who? So work done on the system, it will be what? I'll give you an example. Let's assume I am the system and somebody is the surrounding, right? If I slap the person, the slap was done by me, right? And it was done on the what? The surrounding. That's the next person, right? If the other person retaliates, that means that person is now the one doing the work on me now. Do you understand? So work done by the system is always opposite to what? Surrounding. So the difference between this formula, class, look up. If I use this guy, delta E equals to Q plus W. Pay attention. The only difference between this formula and this is just the sign convention. If I'm using this formula here, right? Since here is already minus, work done by the system will no longer be negative here. It will now be what? Positive. Do you get? If you're using this formula now, class, listen. This sign convention is for this formula, which is more like the acceptable one, right? But if you choose to put here to be minus, right? Work done by the system will no longer be what? So if you're using this formula, work done by the system will be positive. And work done on the system will be what? So that's the difference between both of them. You're going to get still same what? Answer. So I'm not going to be allowing us to do this. It's not, will I say allow? No. I will not tell us not to go with this. But do we understand this guy? Please, emphasis on this, because I know this department. Most of the times, they will not use the word what? By the system. Because if they use by the system, a lot of persons will know, right? On the surrounding. If something is done on the surrounding, something must do it. Right? And who is going to do it? System. So let's take this question and see what we can make out of this. 2 questions and then wrap it up for today. An electric motor does a 200 kg of work driving a belt and loses 35 kg as heat in the process. Please, the kJ stands for kilojoules. What is the change in the internal energy of the electric motor? This question is under first law of thermodynamics, is it not so? So for me to, let's use, this is a statement of first law, Q plus W. If I'm using this plus, this is a sign convention I'm going to stick to. From here, change in E is what I'm asked to find. The system in this case is the electric motor, which they says does 200 kilojoules of work. Is it not so? Class, that statement, is it work done by the system or on the system? Because it is the electric motor that is doing the what? The work, right? So I'll say 200 kilojoules. But since it said work done by the system, electric motor does work. That means the work is done by the system, right? Work done by the system is what? So I'll come here, I put what? Minus. Please, I want to use a two formula to solve so that you see the difference. So here I come here, I say Q. They said in the process of doing that work, it lost how many heat? Lose, is it giving out or receiving? Giving out, right? Is the heat going to be minus or plus? Because that's exothermic, right? Heat lost. So this becomes minus 35 kJ. The minus is because work done by the system, right? Minus is because heat was lost in the process. So I'll say delta E equals to Q plus W. Now this becomes, class, always ensure that the units are uniform. If this guy was joules and this other guy is in kilojoules, you need to convert one to the other. Most preferably, convert the kilojoules to what? Joules. Because so here, since both of them are kilojoules, there's nothing to convert. Is it not so? So I'll say minus work is what? Heat is what? Minus 35 plus minus what? 200. Plus minus is minus, right? This becomes minus what? 235 kilojoules. That becomes my internal energy. Class, what if I had wanted to use this second formula, Q minus W? Look up. Delta E, question mark. Class, remember I said, if you're using this formula, work done by the system will no longer be negative. It will now be what? Positive. I just told us it's opposite of this, right? So I would say, instead of having minus 200, I'll have what? Plus 200. My Q will remain unchanged, right? Heat lost is going to be what? Minus 35 kilojoules. So I'll say delta E is equals to Q is what? Minus 35, right? Minus, this guy is what? Minus plus is what? This becomes what? So which of these two formulas would you prefer? Please put down. Calculate the change in internal energy. But please listen. You see this stuff you are doing here? Any of these terms, you can be asked to solve for it. It must not always be what? Right? The first example we are solving for this. The second example we are about to solve is still for this. But do not conclude that it's always delta E you're going to solve. They can give you delta E and you're asked to solve for the what? Heat. Please put down. Calculate the change in the internal energy of a system for a process in which the system absorbs 140 joules of heat from the surrounding and does 85 joules of work on the surrounding. Now we have solution. I would say delta E equals to Q plus W. Now my delta E is what I'm asked to find. My Q, they said it absorbs 140 joules of heat. Absorption of heat means gain of heat, right? That means the sign will be what? Plus 140 joules. Now the W, they said, and it does 85 joules of work. Is that work done by the system or on the system? Because it is the one doing it. So that's work done by the system. And since we are using this formula, by the system will be what? Minus. So we say work done was 85 joules. But since we are using Q plus W, Work done by the system is always minus. Once again, always ensure that the units are uniform. If one of these units is joules and the other guy is kilojoules, you must convert the joules to kilojoules or vice versa. Most preferably, always convert to joules. Or depending on the options. If it is OBJ question, look at the options. Is a final answer in joules? If the final answer is in joules, convert the kilojoules to joules. If the final answer is in kilojoules, convert the joules to kilojoules. That is it. But as it is like this, both of them are joules, so you're good to go. So we say delta E. Anywhere you see Q, which is your heat, you put 140. Plus, anywhere you see W, you put what? Minus 85. So 140 minus 85 is what? 55. Is it 55? 55 joules. So that is that for thermodynamics. Now, from joules to kilojoules, multiply if you want to go from joules to kilojoules, divide the joules by what? 1000. Now, what if you want to go from kilojoules to joules? Multiply the kilojoules by what? 1000. So for those of us that are asking, for example, I have this guy to be joules. If I want to go from joules to kilojoules, this guy will simply be 0.55 kilojoules. Please check 55 divided by 1000. Is it this? 0. So this is going to 0.055 kilojoules. So if you want to go from joules to kilojoules, divide by 1000. From kilojoules to joules, multiply by 1000, and you get your answer.